I've already told you multiple times that big uppercase U is the internal energy of a system. And it's really everything thrown in there. It's the kinetic energy of the molecules. It has the potential energy if the molecules are vibrating. It has the chemical energy of the bonds. It has the potential energy of electrons that want to get someplace. But for our sake, especially if we're kind of in an introductory chemistry, physics, or thermodynamics course, let's just assume that we're talking about a system that's an ideal gas. And even better, it's a kind of a monoatomic ideal gas. So everything in my system are just individual atoms. So in that case, the only energy in the system is all going to be the kinetic energy of each of these particles. So what I want to do in this video, and it's going to get a little bit of mathy, but I think it'll be satisfying for those of you who stick with it, is to relate how much internal energy there really is in a system of a certain pressure, volume, or temperature. So we want to relate pressure, volume, or temperature to internal energy. Notice all the videos we've done up until now, I just said what's the change in internal energy, and we related that to the heat put into or taken out of the system, or the work done or done to or done by the system. But now let's just say before we do any work or any heat, how do we know how much internal energy we even have in a system? And to do this, let's do a little bit of a thought experiment. And there is a bit of a simplification I'll make here, but I think you'll find it okay or reasonably satisfying. So let's say, let me just draw it. I have a cube. And something tells me that I might have already done this pseudo proof in the physics playlist, although I don't think I related it exactly to internal energy. So I'll do that here. So let's say my system is this cube. And let's say the dimensions of the cube are x in every direction. So it's x high, x wide, and x deep. So its volume is, of course, x to the cube, x to the third. And let's say I have n particles in my system. N, capital N, n particles. I could have written lowercase n moles, but let's just keep it straightforward. I have n particles. N particles, so they're all doing what they will. Now, this is where I'm going to make the gross simplification, but I think it's reasonable. So in a normal system, every particle, and we've done this before, is just bouncing off in every